I'm sharing the whiteboard. I think it will be visible. Is the whiteboard visible, students?
Yes, sir.
Okay. So we started the vectors and we did a resultant of vector using triangle law of vector addition. One more law is there. I'm explaining that. After that, we will do dot and cross product of two vectors. So addition, subtraction of vectors. So two or more vectors may be added graphically or geometrically by using the following laws of vector addition. And the first one is triangle law vector addition. I already explained it in the last class. Then according to the triangle law vector addition, if two vectors can be represented by two sides of a triangle taken in the same order, then the resultant is represented completely, both in magnitude and in direction, by the third side of the triangle taken in the opposite direction. You can take the screenshots. So example, addition of two vectors A and B. Suppose that we are having vector A moving in a specific direction and the vector B is moving in another direction. So how to add them? So to add vector B to vector A, so we will move vector B parallel to the parallel to itself as to the place to the tail of V on the head of A. So the last day I explained we use this triangle of vector addition using when the vectors are connected in the head to tail relation. So we will make a parallel vector and we will add attach the tail of vector B with the head of vector A, and these two vectors are representing two sides of a triangle. Then the third side, when we join the tail of A to the head of B, so we join the tail of A to the head of B, then there is one more vector and that is called vector R, which means the resultant of vector A and B, which represents the sum in magnitude, in terms of magnitude and in terms of direction as well. So this graphical method is called head to tail method. Head to tail method of adding two vectors using triangle law of vector addition. Is it clear?
Yes, sir.
Okay. And please respond when I will ask something. You need to reply quickly. So you can take the screenshot, and I'm moving to the next slide. Okay. So commutative property of vectors means the resultant vector will be the same even if A is shifted to the place of B or their place get interchanged. If their places get interchanged, there will be no effect on the resultant of the vector. So this is called commutative property of vector. Suppose that vector A is moving in a particular direction and the B is also moving in a certain direction. then we are making a parallel vector to A itself and joining the tail of A with the head of B. In that condition, the third side will be the tail of B should be added with the head of A. So whereas two heads are meeting in three vectors, that is the direction of the resultant. That is called the resultant. So now suppose that vector A is moving in certain direction and the vector B is moving here. So we can bring B to the head of A. Then in that condition also the resultant will be same. So the vector addition is commutative. It's a property of adding two vectors. So note that the resultant R is equal in both magnitude and in direction. So the above relation of addition proves that the vectors are commutative. Vectors are commutative, and the property that the vector addition is independent of the order in which the vector are added is called the commutative property of vector addition. Is my voice clearly audible to you, class?
Yes, sir.
Yes, sir.
Okay. So you can take the screenshot. Okay. Now associative properties of vectors. Suppose vector A again moving in a certain direction, B is moving in another direction, and there is another vector C. So if the vector A is added, is attached with the vector A, vector B is attached with vector A, and then the third side will be the resultant, that is A plus B. And vector C is attached with the head of resultant of A and B. In that case, when we join the tail of resultant A and B with the head of the third vector C, in that case, the third resultant, that is QR, will represent the sum of all these three vectors of vector A, B, and of C as well. So here we can see this side represents, this side Q, OQ represents the sum of A and B. We attach one more vector with the head of B, that is vector C. Then if I join the tail of vector, resultant vector of A and B with the head of the third vector C, then this side QR also represents a vector, which is the sum of these two vectors, these three vectors, vector A, B, and of C. Vector A and vector B and vector C again. Now we attach the tail of C with the head of A. Then we directly join the tail of B with the head of vector C. Then in that case, the side PR, that is the resultant of vector B and C. So it will be B plus C. If I bring B plus C and I attach it with the head of A, in that case, the other side, that when the tail of A is joined with the head of the resultant BC, then the third side QR will be A plus B plus C in the bracket. This is called associative property of vector. So the resultant R is equal in both magnitude and in direction. So R is equal to A plus B in the bracket plus C is equal to A plus in the bracket B plus C. So the above relation of addition proves that the vectors are associative. So we can represent this in this manner. We have joined this figure 1. this figure 1 and a figure 2 in this one figure. So vectors are associative. Now the parallelogram law of vector addition. So we have completed the triangle law, and on behalf of triangle law, we could learn how to add two vectors which are connected in head to tail relation, which are connected in the head to tail relation. Now the second law, that is parallelogram law of vector addition. So if the two vectors are to be added can be represented both in magnitude and direction by the two adjacent sides. Means the vectors are co-initial. Adjacent side means their initial point is common of the parallelogram. Then the resultant is represented completely in magnitude and in a direction by the diagonal of the parallelogram passing through the starting point of the vector. So it is the second law, bacho. Please take the screenshot, or I will try to send it. Example: addition of two vectors A and B to add vector B to the vector A and move vector B parallel to itself as the place the tail of B on the tail of A. So vector A is moving in a certain direction and vector B is also moving. Now I'm bringing vector B. Now in place of attaching it with the head of A, I will attach the B with the tail of A. Previously, we were attaching the tail of B with the head of A. That was the triangle law. But in the explain it in the class that these type of vectors are called co-initial vectors. Vectors having common initial point is called co-initial vector. Now complete the parallelogram OQRP. Draw the diagonal passing through the common point C, meeting the point A. So that is we are completing the parallelogram. Drawing the parallel side. First, I draw the parallel side QR, which is parallel to the OP, and then the last side, closing side, that is PR, will be parallel to OQ. Yes, Ramaya, you are saying something, Ramaya?
No, sir.
Excuse me, sir.
So, yes, madam.
Sir, can you please explain this example again? Sir, I got logged out because of network issue.
Okay, okay. 1 minute. So now this is a parallelogram law of vector addition. How it is different from the triangle law of vector addition? According to the parallelogram law of vector addition, if the two vectors can be represented both in magnitude and direction by two adjacent sides of the parallelogram, then the resultant is represented completely both in magnitude and direction by the diagonal of the parallelogram passing through the starting point of the vector. So now considering two vectors again, A and B, these vectors are also there in the triangle law A and B. I'm using the same vector, but previously in the when I was explaining the triangle law vector addition, we are joining the vectors in the relation with the head to tail. But the parallelogram law, in the parallelogram law, we join them in a relation tail to tail. That is a parallelogram law vector. The opposite vector is moving in a certain direction, and the vector B is also moving. Now, previously, when we were doing with the triangle law, we were attaching the tail of vector B, with the head of vector A. That is the triangle law. But here in this parallelogram law, we will attach the tail of B with the tail of A. So we are bringing B and we join the tails of both vectors, vector A and of vector B. Now naming it as P and Q. So these are the three vertices of a parallelogram law. So what we'll do, we will draw the parallel line or the parallel side parallel to the OP. The third side parallel to the OP is QR, which is parallel to the OP, and the fourth side, which is parallel to the side OQ, when we join P and R. So hence we are having a parallelogram. Now the diagonal of the parallelogram represents the resultant of vectors. So this is the diagonal OR, which is representing the sum of this vector A and of vector B. So note the resultant is the same as obtained by the triangle law of vector addition. So what is the difference, main difference between the triangle law and the parallelogram law? When the vectors are given in the relation head to tail, we will use the triangle law to add them. And when the vectors are given in the relation or the vectors are co-initial, having common initial point, then we use parallelogram law to add these two vectors. So in the both laws, we are adding two vectors, but the vectors are connecting with each other with the different orientation. In the triangle law, head to tail relation, and in the parallelogram law, tail to tail relation. I think, is it clear? Is it clear,
Yes, sir.
student? Okay. So,
Excuse me, sir.
yes, beta.
Sir, means in parallelogram we have to make a parallel side to OP and OQ.
Yeah, OQ is parallel to PR and OP is parallel to QR. Then the
Yes,
diagonal is representing the sum of two adjacent sides, not of the opposite side, but of the adjacent side. Is it
yes,
clear?
sir. Yes, sir.
Okay. Okay. So the two vectors are represented by the adjacent sides of a parallelogram, and the resultant is given by the diagonal. So this method is known as parallelogram method of vector addition. And here I have mentioned what is the parallelogram law. You can take the screenshot now. Please inform me after taking the screenshot. Only one student has taken. Okay.
Sir, I have also taken.
Okay. So now I'm moving toward the next slide. Polygon law of vector addition. That is, this law is used to obtain the resultant of more than two vectors. So previously we were dealing with the two vectors. Now in the polygon law we will use we will add more than two vectors. So if a number of vectors can be represented magnitude and direction by sides of a polygon taken in the same order, then the resultant is represented magnitude and direction by the closing side of the polygon taken in the opposite order. Always the resultant occurs in the opposite order. Just remember this. Now suppose that we are having vector A moving in a specific direction and vector B is moving in another direction and vector C is moving in some different direction. Now how to add them? So I will bring and attach the vector B with the vector A in head to tail relation. We will use head to tail relation in polygon law. And now we will close the third side, which will represent the resultant of vector A and B. So this is OQ is the resultant of vector A and of vector B. Now we will bring third vector C and we will attach the tail of third vector C with the head of the resultant of vector A and B. And now we will close the third side, fourth side, Q with the R means the initial point of vector P or resultant A plus B with the head of vector C. Then the fourth side will represent the sum of these three vectors. So R is the resultant is vector A plus vector B plus vector C. Now consider one more example. If vector A is connected with the vector B and the vector C is connected in different order, and vector D is also, and vector E is also here, and when we join the first initial point to the head of the last vector. So first look at here again. So vector A is here and vector B is connected with vector A. In the head to tail relation, the vector C is moving in different direction. Vector D is also moving in different direction, and vector E is also moving in a different direction. So what we notice here, all the vectors are moving in different directions. No vectors are parallel here, but vectors are connected in head to tail relation.
Bye, Papa.
Bye. So all the vectors are moving in different directions. Now what we did, we joined the initial point or the tail of first vector with the head of the last vector. So note the triangle law vector addition follows from the parallelogram law of vector addition, and this is the parallelogram law vector addition. According to the parallelogram law vector addition, OB plus OA, OA plus OB is represented by OC. So this vector 1, vector A and vector B are summed up here along vector C. So vector A plus vector B represented along the diagonal in the parallelogram law. Since the parallelogram law, the opposite sides are equal and the parallel, then the represents equal vectors, and OA plus AC plus OC. So it is the triangle law vector addition again. So we can draw we can derive even the triangle law out of the parallelogram law of vector addition. Please take the screenshot. Take the screenshot.
Yes, sir.
Okay. Good. Next slide, subtraction of vectors. Subtraction of vector can be identified by vector addition of one vector with the negative vector of the other. I already explained in the class, so I am just passing it. Resolution of vector. I also explained it, but I will explain it again so that you may understand it fully. The process of splitting up a vector into two or more components is known as resolution of vector. So the splitting of a vector into its constituent components is known as resolution of vector. So the vector into which a given vector, the vectors in which a given vector is split are called component vectors. So the component of a vector in a given direction gives a measure of the effect of the vector in that direction. So rectangular resolution of a vector in a plane, and we can resolve a vector in terms of the component vector that lies along the I cap or J cap or K cap. So consider a vector A which is in xy plane. Uh, it is a xy plane, and the vector A is there in xy plane. So this vector is moving with respect to both the axes, along x-axis and along y-axis as well. So this vector, when we calculate it, we will split it into two its components. The first one along the x-axis, the next one along the y-axis. So the draw line from the head of a vector perpendicular to the coordinate axis along x-axis and along y-axis. So let's draw first line along the x-axis. We draw the perpendicular on x-axis from the head of vector A, then on the y-axis. Now the length which is cut off along the x-axis represents the resolution of vector A along the x-axis as well as on the y-axis. So it is represented by A1 and A2. A1 is the resolution. The OA1 is the resolution along the x-axis, and OA2 is the resolution along the y-axis. So how to represent this? So we get vector A1, vector A2, such that the sum of vector A1, A2 is the vector A itself. So sum of these two sides, this and this side and this side, these are joined in tail to tail relation. Then again we can say it is the diagonal which is representing the sum of vector A1 and A2. So how to represent these? We will represent these with respect to the unit vector along the x-axis and y-axis. So A1 will be calculated in terms of I cap, and A2 will be calculated in terms of J cap. If we have considered the point in the space, then the third side will be on with respect to the K cap. So the value of A1, vector A1 is A suffix x I cap. So A suffix x is the scalar part of this representation, whereas I cap is the vector part. So a vector can be represented in terms of the product of scalar and a vector. So the product of a scalar, a physical quantity, and a vector physical quantity can be a vector physical quantity. So again, A2 is represented in terms of A suffix y, that is taken along the y-axis, and J cap. J cap is the unit vector along the y-axis, and these AX and AY are the real numbers, scalars. You can take the screenshot now. So the quantity AX and AY are called X and Y components of the vector A.
Yes, sir.
I think you have noted or taken the screenshot. Let's move to the next portion. Resolution of vector using trigonometry. So we will pass it and come to the last portion, product of vector. Vector product. So we could learn the how to add two vector or more than two vectors using different laws, triangle law, parallelogram law, and the polygon law. So according to the triangle law, we added two vectors which are connected in head to tail relation. And in parallelogram law, we use the vectors which are co-initial. And polygon law, we use vectors which are moving in totally different direction. And these are the three laws. Now, how to multiply the vector. So that is a product of two vectors. So in physics at class 11th level, there will be two types of product of vectors. First one is a dot product and the second one is the cross product. So the dot or the scalar product and the cross or the vector product. So dot product or scalar product, let's start with the dot or the scalar product. So in dot product, the symbol of multiplication between the vector is represented by a dot only. So it is represented by a dot only. The resultant of product is a scalar value, and the resultant of product is a scalar value. Just say, for example, the work done. When we calculate the work done, it is the product of force and the displacement vector. Force and the displacement vector. But the product of two vectors, that is force and displacement, is scalar. So the scalar dot product gave us the scalar quantity. Therefore, it is also known as scalar product, or simply we can say it is a dot product. Is it clear, class?
Sir, can you please repeat it again?
Yeah, sure. So I was explaining that dot product is the product when we use a symbol of point or dot between two vectors, and this calculation gives us the scalar quantity while we are multiplying two different vectors. The outcome is a scalar quantity. Therefore, the dot product is also known as scalar product. So example, so work is defined as the product of force and displacement. Hence, force and displacement are vector and work is a scalar. So what is the output of a dot product? The output of a dot product is a scalar quantity. So it is a product between two vectors. The output is a scalar quantity. Therefore, dot product is also known as a scalar product. So consider two vectors A and B which are inclined with angle theta between them. So vector is moving in a certain direction and vector B is moving in different direction, and they are having angle theta between them. So the dot or scalar product is given by vector A dot vector B. Vector A dot vector B is equal to magnitude of A into magnitude of B with the angle of cosine between them. Because angle will be there, so we will use cos theta. Whatever will be the angle, 30 degree, 45 degree, we will apply cos here. So when we apply cos, we will multiply the cosine with the product of the magnitudes of the vector, that is called dot product of two vectors. And we can also calculate the direction or the angle between them, that is cos theta is equal to vector A dot vector B upon the product of their magnitude. You can take the screenshot. You have to join the class again, students. You have to join the class again. 3 minutes are remaining. I will take one more class. In that class, we will complete dot product and the projectile motion. Is there any other class today?
No, sir.
Okay.
No, sir.
So you will take class next class today, or you willing that you study on tomorrow? Tell me.
Sir, tomorrow.
Tomorrow. You are having exam very
Sir,
near.
today,
Yaar.
sir.
You must today. I'll take class today only.
Yes, sir, today.
Okay, yes. So it will be good. We will complete the syllabus. Not syllabus. I am trying to teach you, and you will use it the knowledge in your coming exam. So the next is the property of dot product. Dot product result is a scalar value. So whenever you multiply two vectors using dot method, so the product will be a scalar. And the dot product or scalar product is commutative. Means if you multiply vector A with V, then the multiplication of V with A will be the same. Output will be the same. Third, dot product is distributive. So distributive, if you multiply vector A with the sum of B plus C, that will be equals to A dot B plus A dot C. It's a simple algebra, and we multiply the I cap with I cap in dot, or J cap with the J cap, or the K cap with the K cap. It will produce 1. But when you multiply I with J or J with K, or when the different unit vector, you will get 0. So I dot J or J dot K or K dot I will produce 0, whereas I dot I or J dot J or K dot K will give you 1. And the component of vector A and B, that will be A magnitude of A cos theta equals to dot product by the magnitude of B. And components of B will be different, but you will put A first, unit vector A, and in dot product with vector B. You can take the screenshot. I will teach these steps with the help of numerical. Okay, class, please rejoin because time is up for this class. You quickly rejoin on the same link. On the same link, quickly rejoin. It will be shut automatically. Quickly rejoin, all of you.